Alright, good morning or afternoon. Welcome to our Team AC circuit demo video. Our team consists of Raul, Christy, and myself, Emmanuel. And in this presentation, we're going to start by presenting and explaining our AC circuit and how to set it up. We'll begin first with the multisim. Alright, I will show you how to get the measurements right here for the peak to peak, which is the BPP, the BRMS, the period, and just explain the circuit. This right here is the AC power, or at least that's what it's called in multisim. It allows us to change the voltage at any time and the frequency, but for this circuit right here we have 6 BRMS. We can also see the BRMS in this voltmeter right here, and the frequency is 800 Hertz. Now we're gonna go straight to the oscilloscope to find the peak to peak and the period. So we're just gonna push this back, and we're gonna use this right here for the peak to peak. First we have to move the one, that's right here, set to mass, and set to the minimum. Oh wait, okay, no, just cut it. So right here we're gonna start with the peak to peak. For this one you have to put the 2 on this side and the 1 on this side. It's gonna be important when we go to the period. So we right click the 2, set it to max. Oh, wrong one. It's right here. Set it to max. And for this one, we send it to the minimum right here. And we can find the peak to peak right in this section. 16.4945 volts. Now for the period, we just have to go to this area right here. Okay. So we have to set this to 0. 0. Oh. And this one as well. Yeah, just so finally for the period, we just set it the value to 0 to both of them. Here we go. Now for 2. And the period will be found right here. In the T2 minus T1, the period is 1.25 ms. So that's how you find everything in your circuit. Right. So now we're gonna be checking for channel 2. So what we're gonna do is we're gonna set this to 0. We're gonna put this in AC because this is the AC world. Now we're going to be moving this to this side and this to right here. So now we're gonna set the same thing. We're gonna do the same thing for channel 2 to find the peak to peak. And now we're gonna go for the mid right here. And right here, peak to peak, it says 15.641 volts. And for the period, let's go to the start. We're gonna set this to 0. Let's make sure that this time I got the circuit right. There we go. 0. And same thing here. 0. So to get the period, we're gonna do the same thing as we did in channel 1. We're gonna go and set the value to 0. So let's go right here. 0. And the same thing right here. And 0. And just like that, we get the period, which is 1.250 ms. Same thing as channel 1. Right? Now I already set the whole thing up. It's going to be the same thing as channel 1. You go and hit the max for this, and then you hit the minimum for this. So as you can see right here, 15.833 volts is the peak to peak in channel B or channel 2.
Show how one would set up a AC circuit. Here, we already set up our circuit, so I'll show you. So we have in our setup we have a 330 ohms resistor here, and this will be a 4.7k ohms resistor. Make sure that the gold strip is pointing right or not to the left per se, so you get accurate measurements. So you also need 2 oscilloscope probes, one to channel 1 and one to channel 2. Channel 1 is connected to resistor 1, the 330 ohms here, and channel 2 is connected to the resistor 2 area, so here and here, to measure resistor 2. And then we have our function generator probe, just connected here to supply the power. Oop, fell off. And then we have our DMM probes here, to help measure some of the circuit measurements. Now to measure RMS, we need to move the DMM probe from VN RMS1 to resistor 2 over here to measure the VRMS. And that's how you would set up an AC circuit. That's how you would measure an AC circuit using the new way. You want to press buttons on the digital oscilloscope. So to measure volts peak to peak, you want to go to measure. Would be for channel 1, by the way. So for channel 1, go to voltage, then go to VPP, click on the button, and you get 17.6 volts for the peak to peak for channel 1. You do the same thing for RMS too here. You get 6.21 volts for the VRMS. Now to measure time to measure period and frequency, you want to go to time. So you want to click here. Period would be 1.2 around this area, and then we go back to time, go to frequency. Here we go, and that's how you would measure for channel 1. Channel 2, it's using the new way. And the same thing as channel 1. You will go to measure, and for the measure to measure peak to peak for channel 2, you want to go using the new way. You want to go to voltage, scroll down to peak to peak. You get 16.2 volts for the peak to peak, and then you want to go to measure RMS for channel 2, and go to the same place and scroll down to VRMS. You'll get 5.75 volts RMS. Now to measure period and frequency, you'll go to time and you click period and frequency. Now for period, you will get 1.256 ms for the period. Then for frequency, you would get around 800 hertz, and that's how you measure channel 2 in using the new method.
To calculate or measure the period using the old school method of counting divisions. You want to count one full cycle. So from the first positive crossing to the second positive crossing is what I'll be counting. So here we have 1, 2, 3, 4, 5, 6.2 divisions, and the time per division is 200 microseconds. So what we'll do is take the number of divisions, the 6.2, times the time per division, which is 200 times 10 to the negative 6 seconds. That's 200 microseconds. And when we do that, we get 0.00124 seconds. To calculate the frequency, all you do is take 1 and divide it by the period. And once we do that, we get 806.45 hertz. I'm going to find the VNPP, the peak-to-peak voltage for channel 1. First, I position the sine wave so it's at the bottom of the screen, and that the peak is at the middle, right in the center. Alright, so to do this, what we do is count the number of squares going up, because voltage is the y-axis. We have 1, 2, 3.246. So 3.6 at 5 volts per division. So here we have our 3.6 divisions times 5 volts per division. And for that, we get 18. So it's 18 volts peak to peak. To find the peak volts, the VP, we just divide that by 2. We get 9. And if we wanted to determine what our VRMS is, we'll take that peak voltage and multiply it by 0.707. Here we get 6.36 VRMS, but our DMM also shows us our VRMS. School method for channel 2, we are going to do the exact same thing. Measure 1 complete cycle, 1, 2, 3, 4, 5, 6.2. And that, again, was 200 microseconds per division. So we have 6.2 divisions times 200 times 10 to the negative 6 seconds. And again, we get 0.00124 seconds. And when you divide 1 by that number, you get 806.45 hertz. So that we are able to measure the VPP. So we put it all the way at the bottom, move it to the center, and then we're going to count the divisions just like we did for channel 1. We have 1, 2, 3.2, and that's 5 volts per division. So we take our 3.2 divisions times 5 volts per division, and we get 16 volts peak to peak. To find our VP, we divide that by 2, and to calculate the VRMS for the V2 RMS, we multiply that VP times 0.707, and we get 5.65 volts RMS. We can also view that here on the DMM. It's displaying between 5.6 and 5.7 volts RMS.
Alright, this is the conclusion of our project. Thank you for your time. Alright.